Hi everyone, my name is Thomas Kim. Today is February 27th, 2020. This is my 33rd episode about 3D graphics Intel TVB OpenCL Vulkan using Microsoft Visual C++. As of today, February 27, 2020, C++ 17 Lambda does not support recursion. Also, in ISO CPP org, in this website, compiler conformance status, scroll down, C++20 feature, template parameter list for generic lambda. As of today, GCC version 8, Clang version 9, Microsoft Visual C++ version 1922. This is Visual C++ compiler in Visual Studio 20. Template parameter list for generic lambda. This specification will be introduced in C++ 20 standard. In my next episode, I will explain how to take advantage of template parameter list for generic lambda. But in this episode, I will discuss how to overcome one serious limitation of C++ lambda and how to make our lambda support recursion. I will explain how to support recursion in C++ lambda. Without further ado, let's get started. Start Visual Studio Code, open your working folder, click empty space, click this button, 33 Recursive Lambda. Hit enter, click this button, lambda.cpp, Ctrl B. Include talk play fun output.hpp, talk play fun stream auto ender talk play fun ender void test recursive lambda int main. Copy this function name, paste it in function main. Ctrl Shift P, edit configuration JSON. You have to make these system environment variable settings. Ctrl S, Ctrl W. Then the squiggle goes away. In the command prompt, please note that I am using Visual Studio C++ 17 dir cd 33 recursive lambda cl ehsc sdd C++ 17 lambda.cpp fe m.exe. Hit enter. You should be able to build successfully. Now here auto pip int n, if n is less than 2, return n, else return pip n minus 2 plus pip n minus 1. This is simple Fibonacci sequence implemented using C++ recursion. It is far from being optimized, but it is implemented in recursion. So for inti 0 I less than 10 plus plus I stream I pip I, and there now we build once again CLSM. So this is simple Fibonacci sequence. Now we want to implement this Fibonacci sequence using lambda. Now let's try it. Auto Fibonacci failed. Auto n. If n less than 2, return n. Else, this else part is the problem. Don't forget semicolon here. Now, how can we call this function? if C++ standard support this keyword, if C++ standard support this for lambda, we can try return this operator n-2 plus this operator n-1. Then we can try this, copy, paste, string I, Fibonacci failed I. We can implement like this. If this keyword this is supported in lambda. If we build, it does not work. This can only be referenced inside non-static member function or non-static data member initializer. So this might be a static function. We failed. So I will disable this part. Failed. Now I will copy this part again. Paste it here. Now we can try to capture this. We captured. Then we can say like this. But this does not work either. We build again. No, it can't. So it is failed too. Now we can try like this. Oro, Fibonacci, Oro, N. Using ARGT DECL type N. The type of N. Then we can take talk play fun, remove CV reference T. Now we create a struct. We created a nameless struct and we create an instance, dummy instance. This is dummy lambda. Now return dummy run. We pass the argument n. Here auto run argti this argument, or we can just say n. It doesn't matter. This n does not conflict. So if n less than 2, return n. Else return run n-2 plus n run n-1. So we created a simple member function run. So we are calling run in this lambda. I will collapse this part to make it clear. Now we call this function. Okay, string Fibonacci using recursive lambda. Now we build again CLSM. So this lambda, we created a struct, a dummy struct, and in this struct we have created a member called run. Using this recursive member function, using this dummy, we create function like this. Then we call this lambda like this. So we implemented lambda to create recursive function call. I will explain about this programming method in some future episode. This method opens a new possibility that was impossible before. I will discuss this method further in my future episode. Now I will copy this part, copy, make demarcation here, paste. Now I will say Fibonacci static. I name dummy and I delete this. It is now static. We don't need to create object. Now I call this, paste it here, Fibonacci using static recursive member. Now we build again CLS m. So this method also works. It is a little bit more efficient because we do not create object. This method is a little bit more efficient because we do not need to create an instance of dummy. A while ago, I filmed 2 videos about C++ coroutines. If you want to know what is C++ coroutine, please double-click this link. By watching this video, you can implement C++ coroutine by yourself. C++ coroutine will be introduced in C++ 20 standard, GNU G++ version 10. This is GCC compiler, and Clang version 8 coroutine will be supported. If we combine coroutine with a template parameter list for generic lambda, which I will discuss in my next episode, C++ programming opens new possibilities. Please subscribe to my YouTube channel. Thank you for watching.